I'm Simon Burbidge. I'm from the University of Bristol. I would like to invite everybody to come and visit Bristol in the west of England if they're on holiday in the UK, and indeed for the HPC User Forum to arrange a forum there. We'd be very pleased to have you as our guests. I've been at Bristol University for just a year now. I was very privileged to step into the role of an established HPC service which was set up by my predecessor extremely well. So I'm in the very privileged position of being able to step into an existing service and take it to the next level. So I'm just going to give you a little bit of background here into the university. I'm not the world's best speaker, so if anybody has any questions while I'm talking or afterwards, just jump up, wave your hands, and it'll be more interesting that way. So the University of Bristol, situated in the west of England. It's one of the leading UK universities. It's part of the Russell Group. It has quite a high percentage of research. Founded in 1876, so it's not an ancient university, but it's not one of the new ones either. 18,000 undergraduate students. I guess that's small compared to a US university? Yes, no? Hands up if that's small. Yeah. Quite a large proportion of postgraduates and staff, an income of about £600 million, which these days is about the same number of dollars, unfortunately. More about that later. This is a picture to get your attention. This is the Wills Memorial Building. This was actually, although it looks like it's Gothic, it is actually mock Gothic. It was completed in 1929, and it was funded by Mr. Wills, who was one of the benefactors of the university. And in fact, Bristol is a trading port, or has been in the past, and a lot of the money that built the university came from merchants and traders who became very rich in the city in the 18th and 19th century. And Mr. Wills built this building, which looks a bit like a kind of Norman cathedral, and inside it's equally splendid. In fact, it's so splendid that they do tours of the building at weekends, and tourists go around and climb up to the top and look at the bells and the view over the city. The university has quite a history, though. Winston Churchill was the third Chancellor of the university. He joined at the time that this building was built. Soon after, it caught fire and part of it burnt down, but he had it rebuilt, and he was the Chancellor of the university for, I think, nearly 30 years. Okay, a bit more about computing. I'm the Director of Advanced Computing. I look after HPC and research data storage, and also research software engineering. So we have an HPC group. We have over 1,000 users and 500 projects. So that's projects per year. We retire old projects each year and people have to re-enroll. So compared to the number of people in the university, HPC is really quite widely used. We have a research data storage facility, which is not just for HPC, it's for research data in general. Currently we've got 1.6 petabytes of data, and as you can see, a larger number of people there than compared to HPC, because it's a university-wide data store and it's used by people in the arts, whereas HPC tends to be used by people only in science and engineering. Quite a new addition to the group is a group that's led by Christopher Woods, who is a research fellow of the EPSRC, leads a research software engineering team, and we now have 5 people in that group who look after research consultancy, software engineering, software carpentry, all of the exciting stuff that makes HPC different from other kinds of computer-based activities. The Advanced Computing Group is centrally funded in terms of hardware and software, £1.1 million per year. I'm about to write another 10-year strategy, and I'm hoping that we'll be able to get more money than that in the future. The computer rooms and the running costs are separate from that 1.1 million, so the estate's overheads cover the facilities. That's something that might change as people are more interested in the actual costs of running these kind of operations, and certainly as the cost of power goes up. In terms of the way we work, although we're part of the IT department, Our activities are governed by two committees, the HPC Executive and the Research Data Storage Executive. Both are chaired by senior academics, and the majority of people on those committees are academics and users of those services. So we know they're people who will give us the right steer and make sure we don't go in the wrong direction. And those committees both report to the Pro VC for research, so we plug in at quite a high level in the university. So here's a graph showing how HPC is growing. Now, as I'm at a Hyperion conference, I feel a bit embarrassed about putting a graph because that's the kind of stuff they do really well, but I thought it would be nice and I'd fit in. And it kind of shows nicely that since 2011 on the left-hand side of the graph, there's a steady growth of the number of projects and the number of users. And a bit of a chart showing the spread of the usage of the HPC systems across the different departments. I don't know if you can see the text, but you'll see that most of these are science and engineering. Medicine is coming along, we've got 10% now, but the biggest users are physics and chemistry, aerospace engineering. We have relationships with Airbus, who are located in the same region as we are, and also geographical sciences, because we have a big climate modelling group. But I quite like that because it's a nice even sliced pie. One of the things that universities don't like is if you spend all your money on one piece of equipment and only one small group of users use it. So I'm really pleased that we've got a wide spread of different users. This is our current hardware. There's a picture. Pictures of supercomputers never look very good. Since the Cray one, I think computers have gone downhill in terms of style and fashion. So this is, all our computers are called Blue Crystal. Blue Crystal is a kind of glass that's manufactured in Bristol. It's a blue colour, which is put into the glass by putting cobalt in it, and it's a trademark of the Bristol area to have these blue bottles. And in fact, one of our major exports to the rest of the country is Harvey's Bristol Cream Sherry, which comes in one of those blue bottles. So we named our computers after Blue Crystal. This is the fourth Blue Crystal. It came in the top 500 at number 301 when it was launched last year. 15,000 core Lenovo NextScale computer, Broadwell CPUs, and 64 GPUs. So that's something that's interesting. We'd had some GPU users for a few years, so we thought that would be plenty of GPUs for them, but a bit more on that later. And a bit of scratch space. The previous generation, Blue Crystal 3, we still have it. So what we do is we buy a new computer every kind of 3 years or so and keep the old one to take the less demanding workload and for the new machine to have the big parallel MPI jobs to get the best performance out of that. That's got 7,000 cores, so between the generations we're kind of doubling the number of cores each time. And as I said, this one's just used for small jobs now. Although actually both systems are really busy. Although the new machine is twice as big as the previous one, we now have huge backlogs on both systems. The Research Data Storage Facility is something that was unique to Bristol at the start of the decade. We're one of the first universities to establish a university-wide research data storage facility. It's used by all the university, not just HPC users. So we've got videos, we've got film from theatre and photo archives and things like that. We've got 4 petabytes of disk storage now, and we're adding a second tier of tape storage at the moment, which we want to probably increase the capacity by about 10 times. But we were doing some forecasting the other day, and actually I'm not quite sure that's going to be enough for us. So we may have to find some more funding for more storage later on. There's a policy in the UK from the research councils that any research data that's attached to a publication or will be required to continue a research stream needs to be kept for 10 years by the university. So this is the way we can fulfill that. And here's another graph showing that the amount of data storage and data we're storing is going up as well. Again, quite a steady curve. I don't see that changing. I think possibly next year that will begin to go a bit exponential, which is slightly worrying. Okay, challenges. Lack of people to run HPC systems and to write HPC codes. Our university salaries aren't very high. Industry has crept ahead in salaries, and people who are talented in universities tend to get poached away. And the employment benefits of being in a university aren't as good as they used to be. So it's hard to attract staff now. HPC is not IT. We get a lot of people thinking that because it's computers, IT can do it. But IT can't do HPC. HPC is a research activity. It's not doing your payroll or doing your HR or anything like that, although those are very important. I'm not saying we shouldn't have them, but HPC is a bit special. So I think we're beginning to form opinion now. We can't buy in people to look after HPC. We're going to have to grow our own. So from the research software engineering group, we're looking for people who are interested in the real HPC side of things, perhaps not so much in the domain-specific areas, who want to come into our group, and we can teach them about HPC, train them, and then for some of them to become members of our HPC teams. So we're hoping we'll be able to grow the amount of expertise in the UK by creating new HPC experts. We also need to think a bit wider than we are at the moment in terms of the domains where HPC is used. We're seeing new requirements in medicine, the growth of genomics and gene sequencers, new imaging systems of microscopes and CAT scans and these kind of things, all produce digital output, and that output needs to be processed. So this is a growing area for us that we need to accommodate. And even some of the arts and social sciences are now doing some interesting things. I met a professor of philosophy for the first time a few months ago, and in the course of the conversation he said he does computer simulations. And that was like weird. I thought he would just sit there and kind of think deep thoughts. And he told me a little bit more about it. He was using Mathematica to do it, which I thought probably wasn't very good, and we could perhaps give him a Python course or something. But he was very enthusiastic. And also people who are working in English have got documents which have been scanned and OCR'd from 18th century newspapers. One project was looking at poetry in newspapers because that was where most poetry was published in that era. But the OCR systems used to do that weren't particularly good at pulling out the funny formatting that was used in those newspapers. So doing computerized text analysis of the content is quite hard because the OCR hasn't got a very good success rate on getting the text out. And that researcher was looking at the meta-language that comes out of the OCR program and being able to manipulate that data in order to improve the quality and to take away some of the errors that had happened in the original OCR process. And this was somebody who's in English, and she was asking, can I learn to do computer programming? Which just stunned me. So I said, yes, come along to one of our courses. Other challenges, well, the financial climate, and I guess that's the same for everybody. Brexit has hit us hard because the pound fell a lot against the dollar, and all of our purchases, basically for computing, are in dollars. Cost of energy is going up, and also where to put our supercomputers. The newer systems are becoming denser, need more cooling, more power. Your average data center really isn't the place to put these, so you need a facility which can provide you with chilled water that you can plug into the computer rather than just cool air. Looking to the future, we've got increasing demand from our traditional users. We've got people doing climate modeling and want to do more climate modeling. We've got engineers wanting to do simulations of the entire wing of an aircraft, or indeed an entire aircraft. A lot of our traditional users would like to run more simulations so they can explore the parameter space. So previously where they would have done 1 or 2 simulations, they now want to do 20. We have the new users from the non-traditional backgrounds like the arts, like medicine. GPUs, they're great, aren't they? Everybody loves them. Well, this is where the deep learning thing caught us by surprise. We had these GPUs. In the first year of operation, a computer science lecturer came to us and said, I want to teach a master's course on deep learning. can you give me some GPUs? I said, well, we've got 64. And she had to limit the number of students in her class to 60 students because of the number of GPUs we had. She had twice that number of people who wanted to enroll. So this really is the flavour of the month. I wonder how long it'll last. I really have no idea. We're also starting to build a condo cluster so that we've got a system that can cope with more of the capacity workload, and we can reserve our capability machines for doing very large jobs. Couple of recent achievements, another picture there. The Isambard project is a collaboration of local universities in the west of England. We got funded for £3 million for creating an ARM-based supercomputer in collaboration with Cray. So this is being called Isambard because this guy is Isambard Kingdom Brunel, who built the railway that goes to Bristol. He built the bridge over the Clifton Gorge. He built the harbour at Bristol, which is unique in that the water level doesn't change. He built a lot of the buildings in Bristol. He was kind of Victorian genius engineer. So we've named him in honour of that. Oh, and he also built the SS Great Britain, which was one of the steamships that brought emigrants from the UK to the United States. The feature of that ship, it was the first one to have propellers rather than paddles. He took a risk doing that, and it paid off. Very clever guy. And breaking news, HPE, hands up, who's from HPE? Thank you very much. We've been awarded one of 3 UK universities to be part of the Catalyst UK project, which is to create a production quality ARM-based supercomputer. So we're going to operate that computer within my HPC group, and we're going to hopefully prove that ARM processors are not only just as good, but they're just as reliable, and that Linux will work just as well on them as it does on any x86 system. So that's a really exciting project, and I'm really proud to be part of that. So thank you very much. A couple of pictures just to show, that we do stuff on these computers. I think it's always nice to have a nice picture. Now I'm going to have to look at my notes because I cannot remember what these are. So this one is, this is a protein that's found in the brain. It's a receptor, a TRKA receptor, which is important in the prevention of Alzheimer's disease. So we have a big group who do protein docking, and they're looking at what kind of drugs might interface with that kind of molecule. This is from our climate modelling group. This is a picture simulated from the past, or towards the past. I don't know which direction it goes in. But it's showing the surface temperatures of the time before man-made carbon dioxide in the atmosphere started off the warming process. So, if you're doing climate modelling, it's kind of helpful if you knew what it was before global warming started. So I thought that was quite an apposite picture. So that's it. 4 minutes left. Any questions?
I'm curious, how... Thanks. How does a university like Bristol, or previously Imperial, where you were, how do you decide what to buy for a primary supercomputer? Do you look at what others have bought, or is it a wholly, self-independent kind of a process?
So we have to abide by really quite strong EU procurement rules. So any purchase of significant value has to go through a rigorous procurement process. So what we need to do when we're working out what we want is to basically decide the kind of technology which will give us the results we need, and then write a description of what we want to do with it and give it to the vendors, and then they compete with each other to give us the most hardware to do that job.
But I guess my question is, in doing that, in deciding what you want, to what extent do you look at what others have have bought versus just having an internal process?
Oh, yeah, we will probably try and look at all the other UK universities, and we'll try and look at some of the US bigger machines to see where the trends might be going, and is it a good time to buy a computer now, or should we wait 6 months, or should we put GPUs in it? That's, like I said, with the GPUs, we had some, but it wasn't for the reason they're being used now. Okay, thank you.